Today, we are diving into one of the most intensely polarizing, yet absolutely critical subjects of our modern era: nuclear energy. You just have to glance at a headline or scroll through a comment section to see the pure, unadulterated passion this topic ignites. So, we're going to break it all down: the mechanics, the history, and the really fierce arguments on both sides of the aisle. The pro and anti-nuclear lobbies fight furiously, and it's difficult to decide who is right. That quote really hits the nail on the head, doesn't it? It perfectly captures this global stalemate we're stuck in. You've got advocates who see nuclear power as our literal salvation, and then, right across the table, critics who view it as an outright existential threat. Because of that, today, we're just tossing the lobbying aside and looking strictly at the neutral facts.
So, here is our roadmap for today's explainer. First, the great nuclear controversy. Second, fission and enriched uranium. Third, why nuclear is terrible. Fourth, why nuclear is awesome. And finally, number 5, the modern nuclear revival.
All right, let's jump right into Section 1, the Great Nuclear Controversy, unpacking the global debate. To even begin this discussion, we really have to acknowledge the immense lobbying and the heavy, heavy emotional weights that surrounds nuclear power. Because let's be real, it is rarely just about engineering. It's deeply tied to human psychology, our fears, and honestly, our hopes for the future. So because of all that emotional baggage, our foundation today is incredibly simple: fact over emotion. We just want to look at how we got here and how this technology actually functions, because to truly grasp the debate, you first have to understand the science. Which brings us to Section 2, fission and enriched uranium, the mechanics of power.
Okay, so it all starts with fission. Picture this: you fire a neutron at a heavy, unstable atom, like uranium-235, and boom, it splits. That split triggers a massive release of kinetic and thermal energy. It spits out more neutrons, which sparks a chain reaction. It spreads like wildfire. We then harness that intense heat, boil some water, spin some massive turbines, and just like that, we generate electricity. It is elegantly simple in theory, but infinitely complex in practice.
Because as you might guess, you can't just pull raw uranium out of the dirt and toss it straight into a reactor. It demands a highly complex and inherently dangerous step-by-step process. First up, we have uranium mining. Next, chemical conversion takes that raw ore and turns it into a gas. Then comes the really massive hurdle: isotope enrichment. We're talking about spinning that gas in supersonic centrifuges just to isolate the highly reactive isotopes. Finally, fuel fabrication bakes it all into ceramic pellets and loads it into metal rods. And only then, after all of that, is it actually ready to go.
Let's move into Section 3. Why nuclear is terrible. The case against.
The anti-nuclear lobby fiercely points to 3 core reasons why this tech is just a bad idea. First, there's the inherent danger of the enriched materials. The technology required to enrich uranium for a power plant is dangerously close to the exact same tech used to build nuclear weapons. Not exactly comforting, right? Second, the catastrophic risk of power plant accidents. Look, while rare, a failure in a nuclear plant isn't like a failure at a coal plant. We are dealing with a highly volatile physics experiment that can absolutely spiral out of control. And third, the massive, enduring problem of nuclear waste. The byproducts of fission stay dangerously radioactive for thousands of years. Critics rightly argue that we still do not have a foolproof permanent storage solution for this deeply toxic burden.
And critics don't just rely on theories here. They have cold, hard history to back them up. In 1957, the Keystone disaster released a massive amount of radioactive contamination. Then, the infamous 1986 Chernobyl meltdown rendered a huge geographic zone completely uninhabitable. And of course, in 2011, Fukushima proved that even highly prepared, modern nations can be completely overwhelmed by nature. For critics, these aren't just isolated accidents. They're absolute proofs that when this volatile tech fails, the fallout literally spans generations.
Now let's flip the coin for Section 4, why nuclear is awesome, the case for. Pro-nuclear advocates build their entire case on 3 massive pillars of their own. First off, unmatched clean energy output. Nuclear plants run 24 hours a day, 7 days a week. They provide an incredible, totally reliable baseline of power, completely regardless of the weather outside. Second, they operate with practically zero greenhouse gas emissions, which makes nuclear arguably our single sharpest tool for the crucial mitigation of climate change. And third, the incredible technological potential of reusable nuclear waste. Advocates argue that this immense energy density is absolutely our best weapon against a rapidly warming planet.
And honestly, the waste debate brilliantly illustrates how the whole narrative is shifting right now. What critics have long called the big lie, this terrible toxic burden that we just have to bury deep inside mountains for millennia, well, modern nuclear advocates view it entirely differently. They see it as a massively untapped resource. Advanced reactor designs and new recycling technologies are being developed as we speak that can actually take spent nuclear fuel and use it to generate even more electricity. So instead of a traditional liability, advocates argue it's simply a reusable fuel source just waiting to be recycled, essentially turning a centuries-long problem right into a major asset.
Finally, let's bring it all together in Section 5, the modern nuclear revival, synthesis and the future. Right now, we are actually witnessing a global nuclear revival. After years of total stagnation, resources are pouring back into atomic energy, and it's mostly driven by some huge technological evolution. Modern engineers are designing what we call small modular reactors, or SMRs, which are way easier to build and scale up. They're also implementing these brilliant passive safety systems.